Hello all, this is Jeevan Shankar from the Upgrad IIITB program doing my postgraduate diploma in data science. We will now talk about the support vector machines case study which was part of my course. The problem statement. The goal is to resolve the classical problem in the field of handwritten pattern recognition by developing a model that can correctly identify the digit written in an image. In our particular case, we'll be looking at digits between 0 and 9. We have an image of a digit submitted by a user via a scanner, a tablet, or other digital devices as our input. The pixel values of these digits are placed in various rows of the data set. Using SVM, we try to correctly classify the handwritten digits based on the pixel value inputs. So first, we as usual start with the data cleaning and the data preparation activities. As part of the data cleaning step, we check for any blank and NA values. We also check for inconsistent data and any missing values if we also check if there are any duplicate values available and we clean them up as well. As part of the data preparation step, we first convert the number column, which is our output column, to a factor variable. We then split the training and test data set from our input data. We split by 30-70 rule. The reason we are splitting with such proportion is because to address the computation time of the complete model. So we first start off by constructing a linear kernel SVM with a cost of C. So we develop the model and we predict the value on the test data set. As we have discussed earlier, the training data set is a randomly selected 30% of the data and the test data set is 70% of the data. After we develop the model, we test it on the we predict the values for the test data set and then use with the help of confusion matrix we get an accuracy of 0.966. We then move on and perform the SVM by developing a linear model at a cost value C that is equal to 10. We follow the same steps and after we develop the confusion matrix we get a value of 0.97. We then do a hyperparameter tuning and cross validation to get better results. Post this we work on the nonlinear model construction using the RBF kernel. We perform the same exercise by first developing the model and then predicting the values on the test data set. Once the values are predicted, we develop the confusion matrix and we see that the confusion matrix gives a accuracy of 0.925 post the hyperparameter tuning and cross validation. So, which tells us that the linear kernel with C is equal to 10 gave the best accuracy of all the models that we built using the concept of SVM. We can therefore finalize the best model to be the linear model with C is equal to 10. We also observe that training data set need not be the complete data set that is given to us. We can learn the model based on a relatively small data set and test the model on the remaining. Further, we notice that the linear kernel with C is equal to 1 and also the RBF kernel decently make a good model. Thank you.